Question 4. So the probability of not A given not B. So that's going to equal, that's the same as the probability of not A intersection not B over the probability of not B. Now the easiest thing to do here is just to think of your Venn diagram. So we've got A and we've got B, and it tells me that A is 0.35, tells me the inside is 0.13, so I wish I'd drawn that a little bit bigger now. So that's 0.13. So 0.35 take away 0.13, so that's going to give me 0.22. And then this side is 0.45, take away 0.13, 0.32. And then we know that everything adds up to 1, so therefore the outside part has got to be 0.33. Right, now the question's easy. So which bit is this referring to? It's this part here. So it's 0.33, and the probability of not B, so that's everything outside of B, so that's these two, is over 0.55. So that equals 3 over 5. If you're a decimal person, 0.6 if you really want. Right, part B. Explain why the events A and B are not independent. Well, the easiest way of doing this is just to quickly do this. Right? If they're independent, then the probability of A multiplied by the probability of B equals the probability of A intersection B. Well, let's just quickly try it out. So 0.35 multiplied by 0.45, and if you work that out, that's equal to 0.1575, which is not 0.13. So therefore, they're not independent. Now let's have a look at the last bit of the question. So the event C has a probability 0.20. And then, right, okay, so it tells me that A and C are mutually exclusive. And then it tells me B and C are statistically independent. Right, so now I'm going to have a diagram here. Now I'm just looking at that, and it actually tells me to draw the diagram in any case, but I'll draw it bigger this time. All right, so we've got A and we've got B. Right, A and C are mutually exclusive, but B and C do overlap. So therefore, C, it's going to go inside B, but it's not going to go inside A. So I can fill in the easy information. I can fill this in. So that's still 0.22. This figure here is still 0.13. Now I can't actually fill this stuff in yet. All right, we can't do that. But the other bit of information it told me is it said that B and C are statistically independent. So therefore, the probability of B multiplied by the probability of C must equal the probability of B intersection C. And that's how I'm going to work out that one in there. So the probability of B is 0.45 multiplied by 0.20, and that's going to equal 0.09. So that's 0.09 just there. Now I know all of this bit, right? We know B is 0.45 altogether. So take these guys away from 0.45 and we've got 0.23 just there. And again, we know this is 0.2. So therefore that's got to be 0.11. And we know everything adds up to 1. So that will give us 0.22 out there. And then the last bit of the question, find the probability of B union C not. All right, so the easiest thing to do actually is to work out the probability of B union C first. So the probability of B union C means everything around B and C. So that means all of this lot just here. So B union C, if you add those together, that's 0.56. So 1 minus 0.56 gives you 0.44. So 0.44. And in doing that, I just realised I could have just added those guys together.